In problem 5, we're going to be using substitution to solve systems of equations. To do this, what we want to accomplish is solving one equation for a given variable. It doesn't matter which one you choose, just go easy on yourself and make it as simple for yourself as possible. So in problem 1, I am going to use this equation and solve for x. I could just as easily solve for y in the top equation, but just flip of the coin, I'm going to choose the second one and solve for x. So I'm going to add 2y to both sides, and I get x equals 2y, that is a terrible y, plus 6. And now I am going to use substitution. I am going to plug this, and again, that is a y, in for the x in the top equation. So I'm going to have 2 times 2y plus 6 plus y equals 7. I'll distribute and get 4y plus 12 plus y equals 7. Combining like terms, I get 5y plus 12 equals 7. Subtract 12 from both sides, and I get 5y equals negative 5. Divide both sides by 5, and I get y equals negative 1. That is 1/2 of the solution that we're looking for. To get the other, I'm going to plug this y equals negative 1 into any of these equations. I can use this equation, I can use this equation, I can even use this equation because these two equations are the same, just written in different ways. So I'm going to actually plug it into this equation because we're going to use the least amount of math to figure out what x is. So x equals 2 times a negative 1 plus 6. So x equals negative 2 plus 6. X equals 4. Now we have both halves of our solution. The way we write this solution is as a point for negative 1. That is what you are going to type into the computer during your assignment. In this next one, I think the simpler of the two is going to be this one. I'm going to solve for y. So I'm going to subtract 4x from both sides. Then I'm going to multiply both sides by negative 1 or divide both sides by negative 1. Both things accomplish the same goal. And we get y equals 4x plus 14. Now I'm going to use substitution and plug this into the y in this top equation. I'll distribute the 3. Let's see, 3 times 14 is 12 plus 30, which is 42. 6x plus 12x is 18x. Subtract 42 from both sides. 18x equals negative 36, so x equals negative 2. We'll plug that negative 2 into any of these equations that you want to. I'm going to plug it into this one because it's going to make me use the least amount of math. So y equals negative 2 times 4 plus 14. Y equals negative 8 plus 14, so y equals 6. Written in the final solution is going to be negative 2, 6. That is what you'll type into the computer. 2 more to go. Problem 3. I'm going to solve the first one for y because I think that is going to be the easiest thing to do. I just have to subtract 1 from both sides, and I get y equals 3x minus 1. Now I'm going to plug that 3x minus 1 in for y in this equation. 6x minus 2 times 3x minus 1 equals 12. 6x minus 6x, distributing the 2 here, plus 3 equals 12. Combine like terms and I get 3 equals 12. Now that is a really weird thing to come across. Our variables disappeared and we get a false statement. If this happens, if you get 0 equals 30 or 100 equals a billion, something like that, where it's obviously not true, that means that there is no solution. That means that the lines are parallel. In our last problem, we already have y solved for right here, so I'm going to go ahead and plug negative 3x minus 6 in for y in the next equation. Distribute that 2. Combine like terms and we get negative 12 equals negative 12. Now this is actually a true statement. If it's true, that means that these are actually the same line. If it's the same line, then there are infinite solutions.